right way to secure Oracle is today's presentation. And just before we get started, I'd like to tell you a little bit about SkillBuilders.com. We've been around for a while. I founded the company in 1994, and we provide a lot of consulting services around Oracle database, including, of course, security and rack deployment and performance tuning and SQL tuning and other things that you can see on your screen now. We also provide online training and classroom training at company sites around the world. You can visit us at SkillBuilders.com. In December, Pete's going to be conducting a security class, and he'll tell you a little bit more about that just a little bit later. Now, how about Pete Finnigan? Many of you probably already know all about Pete, but Pete is a world-renowned authority on Oracle database security. He's the author of the best-selling SANS Institute book, Oracle Security Step by Step, and Pete has founded PeteFinnigan.com Limited. This is a consultancy specializing in Oracle database security consulting, security audits, and Oracle security training. As I mentioned, in December, we'll be conducting an online class very much related to the topic we're going to be talking about today. So we hope you do sign up for that class and let your colleagues know that that class will be running. So, without further ado, I would like to pass the ball to Pete and bring Pete online here. And I'm going to pass the ball to him now. And welcome, Pete.
Thank you, Dave. Hopefully everyone can hear me, and hopefully everyone can see my screen.
Looks great.
Because thanks, Dave. These webinars are very strange for the speaker because I seem to be talking to a blank screen in a room where I'm sat on my own, so it feels very strange. So hopefully you can ask me some questions, and Dave's going to jump in and read those out to me verbally, and hopefully I can answer some of those as we go along. The first slide is a little bit about me, for those who don't know anything about me. Really, this is why am I qualified to talk to you about Oracle security. I've been doing this for almost 10 years now, full-time. I started with a company nearly 10 years ago, specifically just doing Oracle database security consultancy. And I've moved on from that and started my own company in 2003, and I've done security audits and design work and training for lots of companies around the world. And I also speak regularly at conferences. I'm going to be speaking at the UK OUG conference at the end of November, for instance. Dave mentioned the SANS book. I've also just written 2 chapters for the new Oak Table book, the Expert Oracle Practices, which is on actually the topic that I'm talking about today. So if you're interested in that, then go ahead and have a look at that as well. So let's get started. Quick, I know you can't really respond to me, but if you want to respond as a question later on, that's fine. I'll come back to this slide at the end of the talk as well. This is really just sort of to get you thinking. Obviously you can't respond directly, but how many people here know where their key data is held? So just really get these questions in your head and remember them as we go through. How many people here understand exactly who, real people I'm talking about here, in your organization can see or modify the key data? The data that you really classify as the key or the special data or the most important data in your company. So that wouldn't be configuration data. That would be things like bank account details, or if you work in the health authority, perhaps it's AIDS, HIV status of patients, perhaps it's patient records, perhaps it's credit card details, those sorts of things. You know, how many people understand exactly who, which real people can actually modify or see the key data? And then building on that a little bit more depth is, you know, how many people think they understand the true privilege model employed within their database, and not just the database, the organization. So what privilege model have you built into your application, your database, to protect that key data? The agenda, that was just a little bit of something to get in your mind as we go along. Think about the agenda. What we're going to talk about here is just really review the traditional way of securing an Oracle database. Talk about some of the traditional ideas using checklists, problems with those. Then we're going to introduce what I think is the right method. Then we're going to talk about data flow, privilege access assessment, and then we'll come back to the question I just asked and obviously back it up with some conclusions as well. So, why do we need data security? Why do we need security of the data? Well, it should seem obvious really in this day and age, but it's not that long ago. We go back and people didn't really do anything in terms of securing their data. If I go back 10 years, most companies hadn't done hardly anything to secure the data in their database. That's changing. I'm seeing that a big change in certainly the companies that I deal with, certainly people I talk to at conferences and people who email me questions and so on. There is a much bigger interest in data security nowadays. And that's probably because of a lot of news reports, stuff on the internet, even on national news here in the UK. We see it fairly regularly now about people losing memory sticks in car parks in pubs near Stafford. If you're not in the UK, that really won't mean a lot, but imagine it's somebody losing a memory stick in a car park in outside a pub in New York. And often these are military people or they're government people. Even just recently there was data lost from a major insurance company, I think it's Zurich Finance, and the FSA, the financial regulator in the UK, has fined them for every piece of data they lost. So it's becoming serious. People are having to sit up and listen. If we contrast that with the security world, the researchers, the people who are writing papers, the people who are talking about this stuff, there has been people finding security bugs in Oracle database software for around 10 years, maybe a little bit longer. Oracle first started creating security alerts around 10 years ago, maybe about 9 years ago. So people have been interested in it for a long time. The initial stuff was fairly basic. It was probably aimed at the same sort of level as any software, so network security issues. So a lot of the initial stuff was around the listener. So it was targeting the Oracle software, but it was based around the traditional type of attack. Then we moved into the stuff that relates to Oracle specifically. So people found exploits within package procedures in the database. So the traditional, the most famous SQL injection type bugs have been reported, found, fixed, Oracle release patches. Often when these exploits have been, the bugs have been found, people create exploits demonstrating how somebody might exploit this issue. Often the target with these exploits is to grant the DBA role to somebody. So you might see an exploit that perhaps targets the DBMS metadata.getDDL package, for instance, and maybe the payload of that exploit is grant DBA to Scott or grant DBA to public. The reality is that these exploits are out there and people could download them. They're on the internet. Anyone in your organization, whether they're in the IT team or they're just a business user, could download these exploits. They could run them against your database. They could cause havoc. They could steal data. The reality is that unless you've got some actual technical knowledge of your system, all they're really going to do is like bragging rights, a script kiddie type thing. They download something, they escalate their privilege. Without knowledge of what to do next, it's quite difficult. They have to spend time understanding it. So this really leads you to the thought that the people who are going to do the most damage are the people who already have technical knowledge of your system. So the developers, the IT staff, the DBAs, the administration staff. We've got a lot of things sort of going on here. The actual exploits that are available on the internet are often around grant DBA, as I've just said. The reality is that you don't need to grant the DBA role to steal data. Imagine an organization where Mrs. Smith loads loan requests in a finance company. So people ring up, they say, I want a loan, I want to borrow £10,000. Mrs. Smith loads the details into a computer system, it's queued, and Mrs. Jones, who sits next to her, authorizes that request for a loan, and the end customer gets their money. If you wanted to steal money, so we're talking about reality here, not about technical computer systems, somebody needs to be, maybe the perpetrator is Mrs. Smith. She wants to authorize a loan for herself, get the money, and pretend it's not there by removing some records. Mrs. Smith needs to become Mrs. Jones. They don't need to become a DBA. So perhaps they only need to actually grant an application level privilege, or maybe they only need the facility to insert a record into a single table in a database. There is a lot of things going on here, as I say. Really, the research that's out there, the things you download from the internet, they're dangerous. but without further knowledge, you're not really going to go much further. The reality is you don't need that level of privilege to actually steal something, and this is something you really need to think about. So it's easy to steal. That's what I'm talking about in the middle bullet point here. It's not rocket science. What you really need is just access to various users' accounts within the organization to be able to do something that involves stealing physical things, such as money. So real theft doesn't require complex techniques often. So what happens in real life, exploits can be downloaded for free. Possibly somebody could steal with those exploits, but in reality people steal data or do things not because of exploits downloaded from the internet. They steal them because of the permissions are so weak in databases, because data is just lying around everywhere. We as customers of Oracle who build Oracle databases, we tend to not think about security when we deploy the application. We leave the data lying around. We often duplicate it in massive quantities. So that's really sort of summarization of we need security, and we're talking about the key issue for me, which is the security of the data. We'll now go and talk about the traditional approach. Most people for the last few years, when they think about database security, if they've done something about database security, they basically do some hardening based on a checklist. In the UK, certainly, and across Europe, most databases don't have much work done on them in terms of data security. There are a number of checklists out there. There's the SANS step-by-step, the SANS score, the CIS benchmark, the DoD STIG. Most of them have got similar levels of checks and fixes and tips and so on in them. People follow them generally over this side of the pond. We don't follow them very far on the US side of the pond. I tend to see databases that have been following these lists to much more depth, and that's generally because you've got more regulation over there, so things like SOX and HIPAA and so on. But is hardening a database by a checklist, is it a good idea? Obviously you can't respond to me, so I'll answer it myself. In my view, no. And the reason is that not many checklists exist. Most of them are very similar. They come from a similar sort of source. They've got similar sorts of content, but that isn't the main issue. Most of them are tip-based. We could relate this to the tuning world of the Oracle database. People who've done any tuning in Oracle database have heard of this phrase compulsive tuning disorder. So you go to a website, you find a tip that says set this parameter to this value, application queries, the database runs a bit faster. You pick another tip, you set another parameter to a different value, the database runs a bit slower. Is it a combination of both tips that's causing it now to run slower? So you remove the second tip, you go and look for a third tip, and so on. These checklists are really of a similar ilk. They're really just tip-based. They're about basic hardening. These lists don't focus on securing the data. If we want to secure a database, we shouldn't think about securing the database software. We should think about securing the data. We have to know where the data is. We have to know who can access it. Then we can think about securing it. These lists don't do that. The Center for Internet Security benchmark, for instance, the version 3, has something like 158, 154 pages, depending on how you printed it out, whether you're using the page numbers from the PDF or the actual page numbers. It's really irrelevant. And each page has got a number of checks in it. Maybe there's 300 to 400 checks in this document. If you follow that complete document from beginning to end and you apply all the advice to your to one complete database, is your credit card data or your aid status or your banking details any more secure? No, it's not, because these documents don't mention anything. This is a big problem. The second side of it is that solutions are a problem as well. We could have a time-based solution or we could have a clever-based solution. I'll explain what this means in a second. Often most organizations don't have a dedicated database security person. Often there's a security team, maybe an internal security team in a big enough organization. They're going around and they're really focusing on desktop security, firewalls and so on. They don't generally have somebody from the DBA team involved. If you want to secure your databases, you have to think about money. You have to think about finance. You have to put forward some man days, man years to actually think about securing your database. This is a problem. Securing a database costs a lot of money if you take the approach of following a checklist. Imagine a checklist with 400 checks in it. Imagine you've got 100 databases. That's what, 40,000 things you have to fix. you're talking about man-years of work to diligently go through all of those databases and do all of that fixing. The problem is, as I've just explained, it doesn't say anything about your data. So your data is probably still just as insecure as it was at the beginning. You've brought up the level of basic hardening, but you haven't secured the actual data. The second part of this is that often solutions are not as easy as you think they are, because solutions often need correlating evidence and facts, and things work in tandem. They work differently based on different versions of Oracle. They work differently based on different operating systems. They work differently based on the fact you've got different applications and so on. So one solution for one particular problem in one database might not be the solution in another one. So you have that complexity as well. So generally in the database world, we have to accept that we can't fix 400 things in every database. We need clever solutions. So the time really transfers to the clever part, and we really say that if we have to start off with how much time have we got to do this. We have one person for a year or one person full time. Maybe in a year we want to achieve a certain level of security. Then that person needs to start coming up with clever solutions. So we need to put wrappers around the data. We need to have an onion-based approach. We need to put security around the data at its source. We need to put security around access to the database in terms of people being able to connect. We need to put security in terms of understanding who is connecting and what they're doing, so auditing and so on. So there's lots of things we need to think about, unfortunately, in database security, is that there are some problems with them. The version 3 of the CIS benchmark, I've just picked one thing as an example here. The version 3 of the checklist has been enhanced. They've added solutions to every check. Hopefully you can see my screen here. Check 302 states that all files in Oracle Home Bin must have privileges of 755 or less, or stronger. But that solution then states chmod 755 Oracle Home Bin star. Is that a good idea? I think not. If you actually look at the permissions in that directory, you will see that some files in that directory are actually got stronger permissions already. So applying a solution from a document often may actually weaken the security. So you have to think about what you're doing. And the second point in this slide really emphasizes this, that a solution often isn't as simple as just following an action in a document. So take the example of a weak password. Imagine that you discover that the schema owner for your application might be called Orablog. It's called Orablog in my database. Maybe the password is Orablog. The solution seems to be to set it to a strong password, maybe 15 characters long, with random characters and digits and special characters. Great. But that's not the complete solution. The complete solution should include password management as well. We should make sure that the weak password can't be reset. We need to find out where it's hard-coded. We need to also think about password management for not just the password complexity, but making sure that account's locked if somebody tries to break in. That leads us into audit. We have to think about finding out who's trying to connect to this account and so on. So solutions for Oracle databases are often complex because we need to think about this layered approach. So we need to have multiple things that we're doing. And really the first point was highlighting, don't just follow the list.
Pete, pardon me. We have a question in the queue I'd like to put forth. On the previous slide you mentioned CIS and the CIS checklist. And a question in the queue is, what is the CIS checklist?
Yes, I actually spelled that out on a previous slide here. Center for Internet Security. So that's a website. If you search in Google for Center for Internet Security, or you can go to my website and go to the white papers page, and if you scroll down the white papers page, there's a section on checklists. You'll find a link to it. It's an organization in the States that have created checklists for lots of different platforms. So Oracle, obviously, SQL Server, Windows, Unix, and so on. They've created checklists, lists of things you should do to harden the security. So it stands for Center for Internet Security. Have you got another question, Dave? Or?
And one of our other students has chatted in the website cisecurity.org for that for the group.
Okay, great.
So we're in good shape. Thank you. And I think let me just check the queue. I think, yes, we've got one more in the queue.
Yeah.
Can you give an example with Windows platform instead of Unix change mod?
Well, I mean, this example isn't really about a difference between Windows and Linux or Unix. Really, it's highlighting the fact that you shouldn't just follow what it says in a document and apply it as a solution.
Right.
So in this particular example, I mean, without going and dragging the file from my shelf to see if I can find one, that's a bit difficult in the context of this webinar. It's really pointing out that the chmod command, chmod means change permission on, and we've got 755, so change the permission to 755 to all of the files, hence the star on the end, in the Oracle home bin directory. And really the point I'm making is that that would actually weaken the security because some files in that directory have already got stronger permissions. You know, the equivalent Windows command on a Windows platform that has got file permissions. I don't know what the Windows command is for chmod. I don't normally work on Windows platforms, right? I normally work on Unix platforms, but I hope you understand, the questioner understands that this is really about the issue of not just blindly following a list. It's not really about the difference between Linux and Windows.
Very good. Thank you.
Thank
you, Pete.
Somebody's written that there,
yeah, that I did. Yeah, and I think that's it for now. Thank you very much, Pete.
Excellent. I'll carry on. So just taking an example of the CIS benchmark, I just wanted really to highlight that these lists don't include anything about your personal data or your specific data for your organization. So maybe the data you're particularly interested in your organization is credit card details, or maybe it's HIV status, or it's, in this particular example on the slide, it's personally identifiable information, PII, that's what that stands for. And this one I've picked for two reasons: because it's actually in the file, in the document, but also I don't believe the answer is the right answer anyway. It's not a general enough answer that would suit everybody. So imagine I've got a database and I've got some personally identifiable information in my database. I'm in the UK, so by law I'm obliged to conform to the Data Protection Act. I'm not supposed to let your data be given out to other people. You know, what we're getting here in the document is the solution is encryption. So it's saying when a table contains a large number of columns of PII, so we've got lots of data, lots of different types of data, it can be beneficial to encrypt an entire table space instead of columns. That, in my particular case, generally we're not required to encrypt personally identifiable information anyway to conform with the Data Protection Act. So that's, again, really an example that these documents don't talk about your data, and they also, perhaps when they do, and this is very rare, the answer is very it's very general, and it's not really specific to each person's circumstances. So, excitingly high, there isn't anything in the SCORE document that relates to your data. So it's really just highlighting the fact that you must consider the data first, and relying on checklists is still a valid thing to do, but it's not going to secure. It's really this. The right method to secure the database. We finally get there. We must start with the data. We have to think about the data. What is the key data in your organization? You know, it might be credit card data, it might be HIV data, it could be anything, it could be bank details. We have to understand what that data is and identify it. We then have to understand the data flow and the access to it. So where is that data? Which tables is it in? How does it get into the database? Which types of users type it in screens? Which feed processes bring that data in? Which processes take data out of the database? Which types of users read it? Which backup processes read it? And so on. And then we have to think about the access to it. Who can access it? So for all those different types of access paths, who can access the data? So the whole thing really is about understanding the problem of securing your data. So you have to identify your data and understand who can access it. Hardening is still important, hence it's in red in the middle. It should be part of the solution, so we should apply general hardening to secure the database, but it should not be the solution. We have to start with the data first. Checklists don't mention your data, to emphasize that point from the last few slides. So to emphasize a second point, which we discussed briefly when we talked about two examples of solutions, and the time-based and the clever-based thing, is that overarching solutions are needed with databases. Databases are just too big, too complex. They are generic software. You know, you decide what application you're going to put in it. You create tables and indexes and views and procedures and everything. You know, Oracle is designed as a very flexible piece of software. So you design the structure, you put your data in it. Often people don't think about the security. This is a big problem because there is such a complex relationship between the data, the privileges, the parameters, the people who can access it, the programs and so on. We really can't think about revoking hundreds of individual privileges or setting hundreds of different parameters. It's just not a practical solution with an Oracle database. This is why you must understand where the data is, understand all the different access paths to the data, understand if the data has been copied within the database itself or copied outside the database, understand how the data moves in transit. Is it being accessed through database links from another database? Is it being copied to tape? Is it being sent off through a feed program to another database? Is it being replicated in a test database? We have to understand where the data is, and then the problem becomes much smaller because we can think about putting solutions around the data itself rather than thinking about hardening thousands and thousands of possible combinations of parameters. So this flexible approach, really, we need to concentrate on the data first. So this diagram really is just about highlighting understanding the architecture. So we start off, we have to think about the data. So in my particular example, I might decide that my credit card data is my key data. My credit card data is stored in a table called credit card. It's in a schema called Orablog. It's in the database. We have to then just think, and this doesn't take more than 5-10 minutes to do this. Think about within your own organization, who can access that data, which users can access it, which groups of users. Is there any power users that access it, people using Excel or Crystal Reports or business objects? Are there any backups that take copies of that data? Are there any feeds that bring that data in or take that data out? Is the data being copied to test or development databases? You know, if you secure, you do a lot of work securing your production database, but then every day you copy the data to a test system, but you haven't done any security whatsoever on your test system, you've wasted your time and your money. Because somebody who wants to steal it will know this, and they will simply avoid all of your security, all of your auditing, and just simply steal it from the test system. So we have to understand where the data is. We just do. Similarly, inside the database itself, we need to understand where the data is and all of the access paths to it. So the problem becomes slightly more complex. So the data as a unit or an entity sits within the database. We're understanding how it flows in and out of the database, but then the data itself gets replicated inside the database often. So the data might be stored in a single table. In my database, it's called credit card. There might be a view that allows users to access that data. This causes a problem with understanding the privilege model because there's a set of privileges on the table itself. Maybe we've granted select to Scott, maybe we've granted update to system, maybe we've granted insert to Orablog on that table. But then if there's a view on that table, there is a second set of privileges that allow access to the data. Now, if we actually then granted select to Fred on the view, Fred can see the credit card data and he doesn't have any privileges at all on the credit card table. We have to understand this, and this relationship is not stored in the database. So we have to understand this complex model. We also have to look for copies of the data. So is there any duplicate data? Is the table being copied? Then again, that whole privilege model duplicates itself. So if there are views on the copies, we have to understand all the privileges and access paths to those. There is often sweeping privileges as well. So perhaps there are things like select any table, create any trigger. People with these privileges can also see the data within the credit card table, and they perhaps have no specific privileges on that table itself either. And then we've got all sorts of other ways we might steal the data if we were a thief. And if we're a DBA or a security person, we want to understand these different ways. So the data might be replicated in backups. You know, if you want to steal the data, steal the backup. You know, the data is actually in the data files. If you allow people access to the operating system as root or Oracle, they can simply run a strings command and read the data. If you ship the redo logs or archive logs to another system for DataGuard or whatever, if somebody can read those files, they can steal the data. It's not a copy of the actual table, it's a copy of the change, but it's still data. And over a period of time, somebody would steal enough data to make it valuable to sell it, perhaps. then there are lots of other ways that we can think about. So really what I'm pointing out here is the data isn't where you think it is. The data flows as well. It doesn't just stand still, which is what I showed on the previous slide. Keep those thoughts in your head. So the data access model is not flat. You have to remove the blinkers. If you know anything about racehorses, which I don't specifically know anything about racehorses, I just know that racehorses have these things called blinkers. They're bits of leather that are on their eyes. They put them at the side, and it stops them seeing the horse at the side of them, stops the horse being spooked as it's racing around. Really, we have to remove the blinkers. We have to think, we have to understand the data is not just in one table. It could be in multiple tables. There could be multiple access paths. So the access rights are also not flat, and the data is often replicated in lots of places. Unfortunately, Oracle replicates the data as well for you. So it's not just about the data being replicated in a copy of the credit card table. Oracle is replicating it as well in shared memory, for instance. So every time a SQL statement is executed, Oracle caches that in shared memory, and that may include credit card numbers. So we have to think about all these things. I'll let Dave jump in there. And
I'm losing your audio just a little bit, but thank you very much.
Okay.
Folks, I just wanted to take a quick moment of your time to remind you that we will be hosting one of Pete's classes. That'll be coming up in December, and this is basically a 2-day class. It's going to be 16-hour online. Of course, if you would like this class at your company site, please just give us a call here at the office. But if you go to SkillBuilders.com/security, you'll end up on this page that Pete's showing us now. And as I said, Pete's going to teach this class in December online. We do hope you register for the class called the Ultimate Oracle Database Security Audit Training Course. And of course, with Pete as your instructor, you'll have two-way communication, can ask all your questions, and you will get Pete's tools and scripts for securing your Oracle database as part of this class. You'll also get over a 500-page workbook with Pete's slides and notes, and that's an ongoing evolution of the workbook, so it's a fantastic resource for those of you who need to secure your Oracle databases. So without further ado, I'll pass it right back over to Pete. Thanks for your patience.
So thinking about understanding the data access paths, understanding that the data has perhaps been replicated by yourself in the database, so you maybe made copies of the table. You've maybe replicated the access paths by creating views and procedures that access the data. We're understanding that Oracle perhaps replicates the data because it caches it in shared memory, for instance. We have to think about all those access paths, and when we understand all the different privileges and access paths to the data, that's going to relate to accounts in the database. So we perhaps see who's been granted select on the credit card table, we perhaps see who's been granted select on a view that accesses the credit card table, or perhaps we see who's been granted select on $SQL area because somebody may be able to read credit card details from the shared memory. We need to relate these to real people for it to make sense. So we need to understand the accounts in the database, break them into groups, so groups of users, groups of DBAs, groups of developers, groups of power users, and so on. We can often do this fairly easy simply by asking the staff to give an example of an account of somebody who's a DBA or a developer or a power user, and so on. And we can then relate other accounts based on naming convention or perhaps based on privilege levels that look the same. So perhaps lots of users, there is no naming convention perhaps in your database. Maybe in one database all of the users are called U01, U02, U03. And we can then relate job descriptions based on the fact they've been granted a specific role. So we can easily group accounts in the database, then understand which groups of people can access the data. That's our next task to understand. Once we understand that, we have a really clear picture of who can see the data. Real people can see the data in lots of different ways, and we can understand the privilege model. So this is going back to the 3 questions there. But a little bit of investigation with some slides just showing some technical output from a database. I'm not going to do this live, they're just slides showing some examples. So we're just going to take an example of my credit card table. We're just going to talk about the table itself, the access paths, the encryption. This is the tip of the iceberg. This is just a simple example in real life. Complex. we're not crackers, we're not hackers. We just have to investigate this and start off by asking a question. So if you work in your organization, you're a DBA or you're a security guy, or you're like me coming in external to a company, I ask, what is your specific data? Tell me the name of the table you think it's in and the schema. And I start with that. So in my particular database, credit card, or a blog schema, what's wrong with this? Looks terrible. We've got select granted to public. You know, these examples are based on real life, things I've seen in real life. The big problem here is that the developer of this database where I took this example from, I've not used his names or anything, you know, the idea is taken from a real database. The problem was that the company assumed that the security of the application itself would protect access to the data. So within the database, everyone can see the data in the credit card table. They assume the application level security would fix this. Obviously that's not true. There is still a reasonable number of users in this particular example, and in the real example I took it from, could access the database. So potentially they could see the credit card data. So again, another level of complexity. Don't assume that one layer of an application will secure a layer below it. We have to think about the data. This is a really good example because this tells us to start with the data, start with the security at the source. This is a sort of subtle issue because there is no direct relationship between the credit card table and the encryption routines. So imagine we've got data in the credit card table, we've just shown you there, credit underscore card. We also have an encryption routine which is shown in this slide. So there's a package called orablog, .orablog underscore crypto. I could look for encryption in the database, I can use DBA dependencies, I can look and see if anyone's using DBMS Obfuscation Toolkit or crypto. They're the two packages normally deployed in an Oracle database. 10G in 9i, we only have Obfuscation Toolkit. We could look and see if there's anything there. That's how I found this package in this particular example. So we've got DBMS orablog underscore crypto using DBMS crypto. So, but the problem is there is no direct relationship between this crypto and the table itself that it's used on. The only relationship is they're in the same schema. We have to remember that when you're looking for security, we have to think about multiple levels again. Particularly, going back, we've got the credit card table. We're just using the dependencies view again, and we can see here we're just looking to see if there are any views that access the credit card table, and there is. There's one called CC1. You can see that at the top of the screen. If we did the same exercise again on CC1, we find there is another view that accesses the CC1 view. So we've got 3 layers of access path. And then we'd need to go and look at the privileges on each of these views. So we could, in a naive view, we would just look at the privileges on the credit card. So we might find 3 users who've got select privilege, or in this particular bad example, it's been granted to public. But maybe it's specifically granted to, say, 3 users. But we also need to look at who's been granted access to CC1 and CCNAME. We should probably look at the columns exposed by these views to see if they're actually exposing the data that we're interested in. In this particular case, the credit card number, perhaps the PIN number, perhaps the CVV number as well. So the 3-digit number you get on the back of your credit card. So really, this is just highlighting there is layers of security. So the crypto. So if we look at the crypto, we see the same problem exists. Remember, there's no direct relationship between the crypto and the table, but they're both related because they allow you to decrypt or encrypt. And they're not directly related because you actually, if you can execute the crypto, it doesn't mean you can actually decrypt credit cards because you need access to the raw data. In this particular example, we have it. But in real world, that might not be the case. But there's still an issue. So here we have the Oracle crypto package. It also has 2 functions that access it, CCDEC and CCN. I mean, anyone can guess what they mean. That's encrypt and decrypt. The problem would be that there may be different privilege levels on the child functions. So the CCDEC and the CCN, perhaps the Oracle crypto has not been granted to public. Perhaps it's not been granted to anybody, but there is privileges on the other 2. So we have to think about the layers, really. Understand who can access them. Of the naive query here, because it's really what I can fit in a single slide. We've got a naive query here. We're looking for copies of the data. So we started off with the Orablog credit card table, and I've taken a naive approach here. What I'm doing is just basically saying, are there any more tables in the database that have a column called PAN? Because PAN is personal access number. That's the column where the credit card number is. In real life, I don't do that. I actually see if the table has exactly the same structure. So I'm looking for a table that's been copied, or I look for a table that's got a subset of the key columns, or I look for a table that's got all of the columns, maybe some additional ones. So we take this a bit further, but this is a simple example. So we can see here, we see credit card and we see CC1 at the bottom of this listing, but we also see importer C23. So there's another schema called importer, and there's another table or a view called C23. So this data has been copied. So we need to do the same thing again. We have to go and look at C23, see if there are any views accessing it. We have to look at the privileges on each of these tables as well, because they are copies of the data. We also have to think about things like recycle bin objects as well. I deliberately created recycle bin objects in this example database, but they are copies of the data. Well, here is in the slide where there's lots of access paths to the data. We've got things like sweeping privileges in the database. Oracle brought in a solution of the initialization parameter 07 dictionary accessibility that prevented privileges like select any table from any user who's been granted it from accessing objects in the dictionary. So, for instance, if you had select any table in Oracle 8 days, and this was set to true, 07 dictionary accessibility, you could read the user dollar table, for instance, or you could read the DBA users view, and so on. You could get passwords, hashes, and go and try and crack them. This 07 dictionary accessibility parameter is a solution to Oracle's problem to stop you getting access to the dictionary. It's not a solution to your problems. So this doesn't fix the problem that if you grant select any table to any of your users, they can still read all of your production data. Remember this. Also, it's not just about select any table. Things like execute any procedure. If I've been granted execute any procedure, I could run the encryption routines if they were locked down. I could decrypt the data. If I've been granted create any trigger, for instance, I could create a trigger on a table I have no access to. So if I lock down the credit card table completely, if I've got create any trigger, I can create a trigger on that table and I can just simply select all the data out of it in the trigger. So I could still steal the data. So sweeping privileges is a dangerous tool. It's just highlighting that the data leaves the database. So in this particular example here, I've got an export file. This export file, as you can see, this is actually the blue bits in the middle. They're actually data. Some of it's in text, the white bits, but we've actually got credit card numbers in there that are encrypted. This is an export file. Export files by default are world readable. You know, if I've got access to the operating system or it's been copied to another server that I've got access to, I can just take it home, install Oracle, install it in my own database, and then sit there and work out how to decrypt it. Perhaps I can just steal the crypto package. Remember that even if you lock down the privileges on the crypto, so you revoke all the execute privileges, if you haven't locked down access to DBA source, somebody can just steal the source code, take it home, even if it's wrapped, and install it in another database with the data and decrypt it. So it's so it's actually sitting in the shared memory in $$ SQL text. So the SQL text column of $$ SQL text, because there are some statements in the dictionary of accessing the credit card table using complete hard-coded credit card numbers. Credit cards are available in the data dictionary. So imagine you've got some developers and you've granted them select catalog role. They can view this view and they can steal your credit card numbers simply by polling this view from time to time. Even if you'd used bind variables, then there is a view called $$ SQL bind capture that lists all of the current bind variables. Depending on the size of the database and how often it's accessed, they could be cached in there for a reasonable amount of time, and credit card numbers, if that's the key data you're interested in, are quite easy to recognize. So think about how you're granting privileges to people, because they may actually inadvertently grant access. Some of that, you know, securing data is not complex. Unfortunately, it's not complex in detail. It's complex because we need to think about the hierarchy. So the data isn't just in your credit card table, it's also accessible perhaps from views or procedures that access your credit card table. There are also sweeping privileges like select any table, create any trigger, and so on. We also have to consider data leakage, so the people who are selecting the data from the database or accessing it through reports or backing it up or putting it in test systems, it's just as easy to steal it from another system. So there's no point spending a lot of time on security of a particular table or views if you just routinely copy the data to somewhere else. And there's more, unfortunately. These are just examples. There are lots and lots of other ways that you could actually duplicate the data or get duplicate access to the data. You know, in summary, what we're really saying is we need to understand the data, any data in your database, and we need to understand where it is and how it flows through the system. Then we can think about securing it. Users of your data.
Welcome to GoToWebinar, Web Events Made Easy.
And a lot of default users in it, so take this with a pinch of salt, really. A real system would obviously have lots of accounts that you've created yourself. They're the other side of the problem. So we talk about the data, the access paths to it, but then those access paths don't mean anything unless we relate them to accounts in the database, and then ideally relate them to real people. If we can do that, then we understand which real people can access the data. What makes it easier to steal and makes the problem wider is that imagine you've got Mrs. Smith's account and Mrs. Jones' account that we talked about earlier. The problem isn't just that we can identify that the account, so the account might be called UMRJ and UMRS for Mrs. Smith and Mrs. Jones. If we identify that those two people own those two accounts, the problem doesn't stop there, because if their passwords are guessable, if their password is the same as the username, then potentially any number of other people could access their accounts and steal the data. So we always have to be thinking about how the data could leak out. So this is just an example of running Password Cracker. This is the PLSQL-based Password Cracker that I wrote. I wrote this because I deal with a lot of clients about security, obviously, and quite a number of them have security policies that prevent the downloading of tools like password crackers that have been written in real languages like C, or they're compiled binaries that you're simply not allowed to download them and run them. So I created one in PLSQL that allows the DBA to do this. You need to consider when you run it that this is quite slow. It's certainly not the speed of a C-based password cracker, but we're not trying to break into the database. We're trying to get a picture of the problem. So I ran this on my test database, as you can see here. 60 accounts. It ran for 4.3 seconds and cracked 53 of them. I don't need to do any more. I know there's a major problem with password security in this database. Lots of passwords too weak, copied, and duplicated. So I done this.
Welcome to GoToWebinar, Web Events Made Easy.
Issues with passwords, so shared passwords. So in this particular database, I see system, DBS-NMP, and Sysman have all got the password Oracle 1. That would lead me to believe that probably the password's Oracle 1 in other databases in this organization as well. Or if it's not Oracle 1, it's probably Oracle 2 or Oracle 3. It also implies, because all the key accounts have got the same password, that many people probably know the password. I would then look at the date of the password and see how long it's been set as well. If it's been set a long time, I would then assume a lot of people in the IT department know those passwords again as well. So this emphasizes the problem I talked about earlier of Mrs. Smith and Mrs. Jones. We really have no idea who's accessing data in this database because we really don't know who's using the accounts. So that brings in the security layers again that we talked about before. We need auditing. We need to know who's accessing these accounts and from where. We need to fix passwords. We need to make sure they can't be left as weak passwords. We need to enforce it, in other words. You know, a simple picture needs to be built of the access to the data. We need to understand all the users in the database who can access the data and then try and map that to real people. Then we need to think about solutions. Solutions are very specific, generally, if we go to hardening guides, but we need generic solutions. We need solutions that work across all databases. So things like password policy works on all databases. We need to understand things like default accounts that have been installed, get rid of them if they're not needed. We need to reduce the access paths to the data. That's a general issue that can be applied to all databases. The solution might be different because of different applications, but the principle is the same. Reduce the access paths, reduce the number of people who can access the data. So in other words, simplify and remove and generalize.
Pardon me, Pete. We have a couple of questions in the queue. One from Sarah.
Yeah, do you want to? I've just got. So we've just got one more slide. Do you want to just leave it till I'll just go through this slide, or you can do it now? It's fine.
That's a brilliant idea. Let's do that.
Yeah. Okay. So just the conclusion slide is really just to highlight that we must secure the data, not the software. Quite obviously, we have to use the software to secure the data, but we need to make sure we do it the right way around. We need to start with the data, understand where the data is, understand who, how, why, and when the data could be stolen. So it might even be stolen not even from the database, but the data must have come out of the database in the first place, so we need to prevent the data leaving the database.
That's great. Thank you so much, Pete. A couple of questions in the queue that we'll need your help, your expertise on. First one from Sarah. What to do if a Java or .NET developer uses one database user to connect to the database? I'm assuming for their application.
This is a fundamental problem that on a number of levels, really. If I see quite a number of applications where you create an application, so you create tables and views and indexes and so on as a schema. So we'll just use my database as an example. So I might have created everything in the Orablog schema. So we've got a credit card table, we've got the CC1 view, the CNAME view, and so on. The problem is that if you then allow all your users to connect as Orablog, there is no security, because the Orablog user can do anything to the data and the structure within its own schema. So you'd have to separate the accounts that people connect to the database from the accounts that own the structure. So if you've got an application owned by one schema, don't let everyone connect as that schema. I hope that's what she meant by the question.
Got a few more questions in the queue.
Yeah.
Do you think it would be safer to use externally defined IDs so no passwords are stored in the database?
That's something I come across regularly when I'm doing audits. I see databases where there are lots of Upstaller accounts. So Oracle externally authenticated accounts, obviously not authenticated by Oracle. So you have accounts where the operating system authenticates the user. So you've got an account called Scott. You've got on the Unix, you've got a database account called Upstaller Scott. They can simply log in by typing SQL+/ when they're connected to the Unix of Scott. Seems easy, seems great because there's no password, and at a local level that's okay for certain situations. This used to be the way Oracle worked because this is the way Forms 2.3 and Forms 3 and early Forms 4 worked. That the legacy way of doing it was to have Upstaller accounts. That's okay, but not for general users, because that means that your users are having to connect to the Unix box. And what happened was, for scalability, Oracle introduced the remote OS authent parameter, which basically meant you could be authenticated on a remote Unix box and then connect to the database. The risk there is that you can simply plug your own laptop into the network, boot it up into Linux, create an account and log in without knowing the password. So on that level, that's really not a good idea. That's really frowned upon. I don't like that idea. On the other level of having OS authenticated accounts, we're really encouraging people to connect to the database. If we take that up a step and become a bit more modern, then we've got directory-based accounts. So we've got things like Active Directory, Oracle, Internet Directory, OID. That's obviously a much better solution, because we're using a directory to authenticate the user. That's a better solution, but it involves more technology stack, more money, more licensing, and so on. There are solutions, though, to the password problem. You could actually use things like Oracle Secure Password. I can't remember the exact name of it. Oracle Secure Password Repository or something it's called. Basically what it's doing is that it's using the wallet that Oracle uses for advanced security. But you can install that on the client, you can install that on the server, because you can still be a client on the server, if you see what I mean. You install it on the client, you create a wallet, you use a command called make store, you put in your user accounts, it could be a Windows or a Unix account, You store the user account and the password in the wallet, and then you can do SQL+/. That's not being authenticated by the operating system. That's actually going and reading the username and password from the wallet and silently sending it to the database encrypted, so you can't see it. So the networking is actually protecting it. So that's a good solution, and it's free. You don't need to buy the advanced security option to do that. There's also a free solution called OPR, opr.sourceforge.net, so Oracle Password Repository that's created by a couple of brothers from Europe, the Spit brothers. And that works in a very similar way, but it's free software. And that's basically created their own repository and their own tools for storing the usernames and passwords. A more general solution will be to look at why you're using passwords and user accounts in the first place. Maybe you could use the database to do the work. So if it's for a job or a batch process, maybe you can put the job in the database. So unfortunately, this is quite a big subject. Without having the specific details, it's very difficult to talk in more detail.
When you say put a job in the database, Pete, are you referring to, for example, DBMS Scheduler?
No, I was referring to DBMS Job because there are security issues with DBMS Scheduler as well, because DBMS Scheduler is brought in 10G, allows you to run commands on the operating system. So I was specifically talking about the PLSQL jobs running within the database because there is much less risk with that. So you can put a job in the database to prevent you having to run it from a script on the operating system. There is, if you use the scheduler, and you've got an increased risk that somebody may, run a Perl script or run an OS command directly through the package, or even worse in 11G, we've got